of operational amplifiers such as inverting configurations, non-inverting configurations, addition, subtraction, multiplication, division, summing amplifier, peaking amplifiers, various types of amplifiers we have studied. So now in this particular second module, it is all about the filters. So first let me discuss what exactly filter. Filter is nothing but it is an electronic circuit which separates the complex signals as per their frequency range. So this is the various applications that the operational amplifier is having. The one more important applications of op-amp is active filters. So these filters are once again classified into two categories, two types. So the digital filters and analog filters. So analog filters are once again classified as two types, that is active filters and passive filters. So these active filters are nothing but which consisting of active elements like op-amp along with the passive elements. Passive filters only consisting of passive elements. So applications, they are widely used in the communications and signal processing, wave shaping, and almost all the electronic circuits. So this classification, there are various advantages these active filters are having over the passive filters. So one advantage is the size of the filters, as they are integrated form, used in integrated form, the size of the filters are less. The cost of the filters is also less. So due to flexibility in gain, so frequency adjustment, the active filters can be easily tuned. Okay, so the design is very simple compared to the passive filters. So the most commonly used filters are low pass filters, high pass filters, band pass filters, band reject filters, and all pass filters. So in this particular block, we have a low pass filter circuit. This particular box which consists, let us take, assume, so this consisting of a low pass filter circuits. So I am giving input here and I am getting the output. So here, as it is a low pass filter, only the lower frequency signal, where any kind of a signal if you give an as input, it will only produces the low frequency signals as an output and block the higher frequency signals. Okay, so that is the function of this low pass filters. High pass, once again, if you're using the in the same place, if you're using high pass filter, it will passes the higher frequency signals and blocks the low frequency signals. If you use the band pass filters, certain band of frequencies are passed and the rest of the bands are eliminated. So band reject, certain band of frequencies are rejected and the rest of the are passed. All pass, all frequency signals are passed from input to output side. So next is the difference between the active and passive filter. It consisting of, once again, so active elements like operational amplifiers along with the passive elements. So whereas passive filters consisting of only passive elements. So it provides the gain which is greater than unity and it does not provide any gain. So it can be fabricated in the integrated form, where it is not possible to fabricate it in that integrated form. So the design is simple, the design is complicated. So they use the less power consumption, so they have more power consumptions. So higher operating speed and the passive filters having lower operating speed. So next we have a discussion about the frequency response characteristics of an operational amplifiers or filters. So frequency response characteristics is nothing but it is the graphical representation of variation of the gain with respect to frequency. Now let me start with the frequency response of a low pass filters. So here, so it is the graph plotted against the frequency versus gain. So here, so pass band is nothing but the frequency of the signals, okay, which lies in the pass band are passed from input to output side, low frequency. So pass band consisting of a low frequency signals and stop band high frequency. So as it's a low pass filter, all the low frequency signals are passed from one form to other form. So next is high pass filter. Here stop band and pass band. So high pass means the higher frequency signals, they were pass band consisting of high frequency signals which are passed from input to output side, and stop band is consisting of low frequency signals, so it is blocked. So similarly, so we have a band pass filter. So certain band of frequencies between FL and FH are passed from input to output side and the rest of the band of frequencies are eliminated here. Next is band reject or band elimination filter. So the gain versus frequency. So FL and HS, here certain band of frequencies are stopped and or eliminated and the rest of the frequency signals are passed. So all pass filters, so these filters will pass all the frequency signals from input to output. The thing is, which will introduce us the phase shift between each of the signals to identify which signal is having which frequency. In addition to this, in practice, we are using various types of filters. So Butterworth filter, Chebyshev filters, and Curie filters. But in this particular syllabus, your syllabus, so only Butterworth filters, that is first order, second order, high pass, low pass, band pass, all pass Butterworth filters is included. The detailed discussion about this Butterworth filters we will take in next session.